Okay, welcome, Mr. Pradeep. Thank you so much for this taking time out to be part of this conversation and the series that we are doing on semiconductors.
Thank you, sir.
Welcome everybody who's on the call here. We are really privileged and lucky to have Mr. Pradeep here sharing his insights and also his experience over the years. And I will just give a short introduction of Mr. Pradeep. He's got 20 years experience in circuit design and AI. After India, he went to the University of South Cal. From there, he did his MS over there and then worked with multiple companies in US, including Intel, Texas Instruments. He is himself a startup founder. And so he's seen this entire journey from device physics to AI systems. And then through AI architecture and system design, he got into AI much earlier than the current wave, which is happening right now. And he knows product design from end to end. And he's been a thought leader in the future of AI systems, and he has spoken and presented at multiple global forums in 7 countries. So once again, welcome, Mr. Pradeep. And I will just tee off by, if you could share with us after your MS, how was your journey in US and what took your interest over there? And then you could probably share with us what you saw about this semiconductors thing then and now.
Sure, definitely, Santosh. First and foremost, thanks a lot to you personally and Atria for giving me this opportunity to speak about semiconductors and how AI is actually going to converge with semiconductors and what is the future ahead, right? So, I'll start with my story 20 years back when I went to US to do my master's. I was an average student, to be frank. I did my bachelor's from a private engineering college in Hyderabad from Osmania University. I was not the brightest student, if I may put it that way. But I had a good break. I went to University of Southern California, Los Angeles, to do my master's in electrical engineering way back in 2001. I went there like a typical student. I was not sure what to study. So I ended up taking 9 different courses in 3 different areas, which in hindsight turned out to be one of the best decisions that I had taken. So I studied VLSI circuit design, analog circuit design. I took 3 subjects in that. I took 3 subjects in computer architecture, and I took 3 subjects in signal processing. So these are 3 different domains. And why did I take in 3 different domains? Because I did not know what to do. But as I mentioned, it ended out to be a boon eventually. So with that background, I started working in a battery manufacturing systems company in Los Angeles. Then I moved to Intel. I was with Intel doing circuit design. I worked in Intel California for some time. Came back to India in 2006 and then was with Intel and subsequently with a startup, then with Cypress Semiconductor, and finally with Texas Instruments. For the first 11 years of my career, I was doing hardcore analog circuit design, specification to silicon. So I developed that expertise. And during those 11 years of my career, I would say I would spend at least 10 to 15 years of reading time, if I may put it that way, every week during those 11 years, going back to the basics, understanding everything in detail, why something is working the way it is working. Right from understanding how device physics works, how electrons flow in a transistor, right? So that is one thing again, in hindsight, I did a good job making sure that just because I was in a job, I was not just doing a job. but I was also making sure that I was learning and uh, continuously improving myself for almost 10, 11 years. In 2012, that is where I had to take a decision in my life. I had three opportunities: go back to US. I was doing well in my job in Texas Instruments. My manager from US offered me to move back. And then I wanted to do a PhD. So at the age of 32, I wrote exams with other students, and then I was the topper. Yeah, this is something I should tell you. Usually students mail professors to get into their groups, right? I had a admit from IIT Bombay for my PhD, but I did so well in my exam that the profs called me asking me to join in their groups. I used to get phone calls from professors. But eventually I did not join IIT Bombay. I left my PhD. I had a roll number, I paid the fees and everything, but I decided for whatever reason not to do my PhD and took up entrepreneurship. So in 2013, I decided to start something on my own. So I left going back to US and left a seat in IIT Bombay and decided to build something. In 2014, I left Texas Instruments, and for the first 6 months, again, because I had been studying for the last 10, 11 years, something or the other, right? I continued that, took a sabbatical sort of a break. Right from linear algebra to neuroscience. I had a good time in taking up various courses and Coursera, and this is like 10 years back when online courses were not that famous. I studied everything from linear algebra to neuroscience to figure out what to do next. Uh, and I think that is where I realized in my corporate career also that the future is not going to be about typical engineering, but engineering with a lot of automation, right? AI, artificial intelligence, was not this loosely used 10 years back. Today, I do not see a company, I do not see a startup that does not talk about AI. But 10 years back, nobody knew about machine learning. Nobody knew about TensorFlow. Nobody knew about PyTorch. I mean, they did not even exist. Yes, I had this feeling that the world is going to change. And I think it's just a matter of coincidence that GPUs took off big. In 2012, 2013, you guys should, the students should figure out how actually this AI boom started. There was a paper by a team in University of Toronto, specifically the author Alex, I forgot his last name. He came up with this paper for object classification, image classification in 2012, where the accuracies jumped from, I think, mid 70s to high 80s. That was the turning point when the world realized that AI is going to go big, and people started seriously looking at AI. This was in 2014, 2015. That is when Google started investing into TensorFlow and so on and so forth. Again, as I mentioned, it is just coincidence that I started looking into AI around the same time frame. And then I started my first startup in 2014, 15, building AI solutions in the industrial automation space. Subsequently, we got into an accelerator in the US called Alchemist. It is one of the top accelerators where we were basically building solutions for businesses. Coca-Cola was our flagship customer. So we started building image recognition solutions for Coke. Remember, I told you way back in 2001, I studied signal processing. So although my career for the first 10 years was in circuit design, when I started building solutions for Coke, my background in signal and image processing helped me. So you never know what you study, how it will turn up in your career, right? And at the same time, we started using GPUs, and people who in those days were using GPUs had to learn about computer architecture. So that is how computer architecture came into the picture. Because if you look at the fundamental architecture difference, right, between CPUs and GPUs, these are massively operating ALUs, frankly speaking. I mean, you have 5,000, 6,000 cores of simple ALUs in layman terms. So if you understand computer architecture well, you would know for which applications you would use GPUs, so on and so forth. So yeah, we started building solutions for Coke in 2016. We built what is called as a planogram solution for Coca-Cola for almost 3-4 years, deployed the solutions across the globe. So I had personally traveled to interior places in Mexico, went to places like Bulgaria, Hong Kong, China, I mean, all these places to deploy these solutions. Yeah, things were going good. And in 2019, I exited that startup. And thanks to COVID, for 3 years, there was nothing that I think the whole world was doing. I was also, in a way, enjoying life at home, not doing much. But because I had this unique experience of building solutions in AI since 2014, right? And then for the first 10 years of my career, I had this experience of building ICs. I sat down back to the drawing board and figured out how we could converge AI with circuit design. I think today I can confidently tell you that me and my team, we are one of the very few guys in the whole world who have the knowledge to actually converge semiconductor design with AI, and we have had good traction. We are in the early stages of building our startup. There are good customers. We have some customers in East Asia and India. And definitely we'll find some here in North America. Yeah, I think that's the journey. And going forward, our focus would primarily be on platforms that can converge artificial intelligence with circuit design.
Fantastic. I mean, just hearing you, one realizes what a journey you have had. And though you managed to share it in 10 minutes, I can imagine the extreme hard work that you have put into the continuous learning. Even saying that I have put in an hour every day, it accumulates to, and I think to all the young people who are listening, there is the power of compounding. And I think Mr. Pradeep is an amazing example of that, that even if you put an hour every day in your own growth, in your own self-improvement, look at where he has been. So continuing that conversation, I wanted to ask you this. I know that you believe a lot about basics and fundamentals. And even right now, you mentioned it a couple of times, that even though you had studied subject for almost 11 years, you still are putting that time to learn about the basics and fundamentals. So this is really for the electronics and electrical and communication engineering students out there. Why do you feel that? So a lot of these students are now graduating, or they might be in their moving to their fourth year, for example. And the question which would be there in their mind is, why should we be learning basics and fundamentals now that we have done this for such an amount of time? So what is the message that you would like to give it to them, and especially in the context of the semiconductor thing that we will now shortly talk about? Why is it so?
Sure. It's a great question and a very, very important one, right? And I'll answer it in two different ways, because everybody doesn't have to understand it in one single dimension, right? Okay, first and foremost, the simpler way of answering this is, if you do not have good fundamentals and basics, trust me, there is only so much you can learn. There's only so much you can build, and there's only so much you can grow, because it will catch up, right? Can you build a three-story building without having the basic foundation put in a proper manner? You cannot, even having the first floor properly built. All of us are engineers here, right? If you do not have your foundation well, you cannot build your house. It's as simple as that. If you do not have your foundations learned properly in circuit design, or for that matter, any engineering domain, there's only so much you can learn. And that is the problem with most of our engineering students, or personally, this is what I feel. I interview quite a few students to hire and stuff. I Everybody talks about AI, even in the current pool of engineering students, right? Everybody talks about AI. Everybody talks about doing great stuff. Yes, good. It is good to be aspirational. You should be aspirational. But are you good in your fundamentals? Right? That is what I check out. If your fundamentals are not good, then being aspirational will not really help. Right? So you have to be good in your fundamentals to build great things. If you do not know simple algebra, and trust me, most of the students that I interview, 95% of them do not have good foundations in algebra, but they talk about building AI systems. And AI is nothing but matrix multiplication in layman terms, right? And what is matrix multiplication? It is simple linear algebra that every student would have learned in their first year of engineering in math, or even 10th or +1, +2. So yeah, bottom line, you have to have your foundations in place to build great stuff, right? That's one. The second thing is, when your foundations are strong, right, you can actually learn a complex things by breaking the complex things into sum of parts. That means you take a complex concept, you can always break it into smaller parts, which are foundational in nature, fundamental in nature. Understand those fundamentals, and then you have this whole network of parts coming together, and that is what becomes a more complex integrated system. And you will be able to break a complex system into parts only when your fundamentals are strong. So I think these are the two reasons among many more that I can give you at this point in time of why fundamentals are required. And the biggest difference in education between India and the West is, in the West, people focus on fundamentals. So I would rather choose one or two subjects and go deep into them and learn well about them, instead of spreading myself then in 54 subjects that I don't know how many subjects the current set of engineering students have to learn. But when I studied or did my engineering, there were 54 theory and I don't remember, maybe 12 or 14 practical courses. I, I understand there are some systematic issues, but there's only so much we can do in correcting them, right? But bottom line, I would strongly suggest focusing on fundamentals, and that will eventually help you.
Beautiful. Really love that point about how you can't build a structure unless you have a strong foundation on the ground.
Yeah.
So coming to the AI part of it, the question is, what got you interested in artificial intelligence at that point of time, and what sustained your interest for this so long? And this current wave that one is seeing in terms of interest, and in Google Trends also, it continues to be trending very high, and everybody's now seems to be dabbling with it. So
Sure.
what got you interested? What sustained your interest? And how do you see the current wave of interest, and where is it going?
Definitely. So For me personally, right, as I mentioned, my journey into the world of AI started in 2014. For the first 10, 11 years of my career, I had been doing only circuit design. I never wrote a single line of code until 2014. Uh, uh, right, it was only circuit design, circuit simulations, bench validation. I mean, the entire the ecosystem related to chip design. That was what my focus was on. But in 2014, yeah, as I mentioned, I started realizing that things will change. We were at the point of inflection where CPUs started getting more and more powerful. GPUs came into the picture, so on and so forth. So that is when I think again it's back to basics where I realized if I want to or intend to explore, learn, and understand AI and machine learning algorithms, the best way is to find algorithms and methods that replace me or perform my own work. So whatever I had been doing for that first 10, 11 years, right? Is there something like an agent, an engine that I can build that will replace my own self? And this is an experiment. It's a thought experiment that everybody can do, right? You don't have to really know AI as such. Uh, but just be imaginative in thinking, hey, I have done this for the last 10, 11 years. Can I build an alter ego of my own self, like an agent that can do my own work, right? And take simple examples that can be built to replace your own self. It's an experiment that you can play with your own self, and then you will figure out. That is how your journey will start in the AI world. Trust me. I mean, AI today, there's a lot of hype, but if you stick to fundamentals and if you just find something in your own life that you can replace with AI, you should go ahead and build it. You'll enjoy it. You'll have fun because you're building your own self. And that's what I did even with my self, right? I was doing basic circuit design 20 years back in Intel. Electronics students may understand this. There's this circuit called inverter, which is a two transistor, a PMOS and an NMOS transistor circuit. That's the most basic circuit you will come across in chip design, but the fundamental one. And the entire digital core in any chip is built on universal gates, like a NAND gate, inverter, and a NOR gate, right? So, and for the first year of my job in Intel was to design inverters for running high-speed clock circuits. So in 2014-15, when I started exploring AI, I was like, okay, let me build an agent that would do the work that I had done in 2003 or 4. That's how my foray into the AI world started. Right. So that is one. The second thing, over the last few years, I have started realizing that, and this is a saying even in the industry now, it's very important for students to know about this. And this is an unfair advantage that the younger generation have. All the seniors, people of my generation, right, they are scared. I'm being frank and open with you. They are scared because 20, 25 years of experience. But today there are tools out there that a fresher, a person with much lesser experience, with 1, 2 years experience can come, leverage those tools and replace the senior folks. So the high salaries, and salaries are huge in the circuit design world, in the chip design world. A person with 20 years experience can draw a salary of 1.5 crores per annum in India. I'm not joking. This is the reality. People with good experience in circuit design or chip design, excuse me, demand amazing salaries. And even if you look at freshers, right, There's an echo. I think somebody has to mute. Yeah. So freshers, I think good freshers in good companies can start with a salary of 15 plus lakhs, right? And then that exponentially grows over the due course of time in the chip design industry, right? But is this sustainable over the long run, especially for the senior experienced folks? The answer may be no. And the reason is there is this saying in the industry that AI will replace you, right? But more intuitively, that particular experienced person may not be replaced by AI per se, but somebody who knows AI in that particular domain will definitely replace him. So this is important to understand that domain knowledge is very important. That is like the foundational stuff that we are talking about. But if going forward, people do not learn AI and start applying it in the core engineering domains like semiconductors, they will get replaced by somebody who knows that domain as well as AI. It's important to understand that your domain knowledge is fundamental and is required. Without that domain knowledge, just AI will not help. So domain knowledge is necessary, but may not be sufficient.
Fantastic. That's a really good summary. And I hope all the youngsters who are seeing this as well as who will see it later will take confidence from the fact that you said that the older guys are running scared.
Yeah.
And I really like the way you highlighted this point that it's not about AI taking your job, but it's if you know AI and you know how to use it, then you will definitely be better placed than somebody who doesn't know how to use AI. So I think that's a very valid point. And I think that leads really very well to our last question, because really in the next session, we are going to go deeper into this convergence of AI and circuit design and semiconductors, which, like you said, you are one of those very, very few, and your team is one of the very, very few teams in the world who's doing something like that. So that's the part 2 of this session where we'll discuss that a lot more. But just to give a flavor or a teaser of that what made you think about combining AI and semiconductors? And within that specifically, why reinforcement learning? What encouraged you to really consider that?
Yeah, excellent question. And this is something that I'll go deeper into in our next webinar, right? But as a teaser, I'll start with this. For people, I don't know how many CS students are in this call, but for electronic students, I'll give a primer. So in artificial intelligence, at a very high level, you can you have basically 3 sets of methods for building, say, neural networks or any AI engine, right? There is supervised learning, there is unsupervised learning, and there is reinforcement learning. For supervised and unsupervised, you need large amounts of data or data sets to basically train your algorithms or networks, right? And this is the advantage that the big companies like a Google or a Facebook or Microsoft, Amazon, they have it. They have large data sets. And that is why they have this upper hand in building amazing AI engines. And startups like OpenAI, although we call it as a startup, but it is beyond a startup now, in my opinion. They have basically mined Google and got this data and were shrewd enough to build their engines on Google, right? And that is what Google is complaining about. Anyway, long story short, unless you have massive amounts of data or data sets, you will not be able to come up with good AI algorithms or good AI networks. That is the limiting factor when it comes to supervised and unsupervised learning. Coming to reinforcement learning, you do not have to have data sets to begin with. This is where we were smart enough to figure out that if we can build connectors between simulation tools, like in semiconductor world, you have simulation tools, and then AI agents. If you can build connectors through what we call as experience learning, that's the beauty of reinforcement learning. The agent itself will start playing with or experimenting with various parameters to figure out the right direction in which the learning has to happen and over a period of time. In reinforcement learning, the only thing you have to give to the agent is a simulation engine, time, and compute. It will figure out the right direction in which the learning has to happen, and over the period of time, due course of time, the learning will happen. So that is the reason why we went with reinforcement learning, because we do not have large data sets to leverage. We compensated it with experiential or experimental learning and figured out mechanisms to build it. And this is something that even the likes of Cadence or Synopsys, these are big companies that electronic students would know, are now working towards. So they have large teams that are working. There's a lot of investment going into this. Cadence and Synopsys and all the EDA, electronic design automation companies are investing, if not billions of dollars, at least hundreds of millions of dollars. And they also understand that going forward, if they do not build AI engines or incorporate them in their tools, they will be at a disadvantage. So they are investing into it. And for students, right, if they develop this expertise in both circuit design and AI, then it's a very good opportunity for them to apply to these companies if they learn it the right way.
Fantastic. I'm really excited for the next session already. So thank you so much for this brief interaction. Of course, the next one is going to be now more detailed into the way that you're operating and why you feel that's the future of at least the learning systems, about how we can combine. Like I have been saying this to the students out there, that there are a good number of ECE students, there are a good number of AI students, but your ability to combine AI with semiconductors, they are very, very narrow set of people, and hence they'll become very, very prized going forward. And hence, obviously, you will get fantastic jobs. And today, while getting a job might be right up there for students who are passing out, or even those who are already in jobs, who have been in circuit design for some time, might be looking at all of this and saying, am I irrelevant? The key is that if you can combine this, then the world is going to come to your door rather than you knocking on doors to take yourself ahead. So thank you, Mr. Pradeep, for today's session, and really looking forward to the session next time. Thank you so much.
Definitely. Thank you. Thanks for your time. Yeah.
Thank you, everybody. Thank you.